Hi guys, welcome back to part two of this video. So now we're going to be looking at some diagrams from Cognity and also looking at our second learning objective. So let's get into that. So I've got Cognity opened up here and there's some really good diagrams like this one right here. So we've briefly talked about this, but I think this is a little bit more clear with the dotted lines. So we've got the 300 volts on the outside. And then as it gets further and further in, 350, 400, 450, and 500 volts. Notice that the distance isn't always equal in terms of the amount. So that is a particular thing to note here, is that the distance and the voltage drop isn't always consistent in terms of the spacing with each other. These are, again, two interesting diagrams that I wanted to point out, which includes two like charges. And with negative charges, it's the same, but the arrows are pointed in the opposite direction. This is another really interesting diagram with two opposite charges. And this is probably the one that's really well done. So I'm going to go back to our notes section, and we're going to talk about that. Okay, so I briefly mentioned this already, is the dotted green lines are lines of equipotential. I think that's pretty clear from our examples earlier already, excuse me. Now we're looking at a situation where we've got two charges of equal potential, and you can actually see what I was explaining a little bit earlier here is that if the center of the two different charges was 50 volts each, and it traveled from the center of one to the other, then that would be a change of 100 volts. So that is, again, the idea of the potential difference. So we're assuming both charges are the same. So maybe like 5 times 10 to the negative 6. And this is 5 times 10 to the negative 6. This would be negative. That would be a positive. And so as a charge moves through, I'm going to have to draw that outside of this. So as a charge moves through this, whoops, as the charge moves through from this point all the way over here, it can reach a point where the voltage is considered zero. And the reason happens because there's two opposing charges. So it doesn't get infinitely smaller and smaller. Well, it does get smaller because it's getting negative. But we also want to keep the idea that because there's quite a strong charge that's pulling it inwards, the relationship isn't that it necessarily completely drops off, but that the strength is going to be actually roughly equal along here as well. Okay, the strength is equal, but the voltage changes as it moves across this. Okay, so as it moves closer and closer, it gets into what we call a negative voltage. And the idea of the negative voltage really does, in this case, it comes from the idea of trying to express that it's moving towards another charge that's going to pull it in towards it. And they're trying to represent different directions in terms of where it's coming from the positive and the negative charge. Don't worry too much about it, but do recognize that in the middle is 0 volts, and then it gets into a negative value as it moves towards the negative charge. Okay, so in terms of our learning objective, our second one, we're trying to explain what an electron volt is. So the definition is that it's the amount of energy needed to move an electron through a potential difference of 1 volt. So again, if we think about this as a big Q here, if this was 51 volts and this was 52 volts, it's the work required to move an electron through that. So this is actually pretty straightforward. The charge of an electron is 1.6 times 10 to the minus 19. And we're going to multiply that by a volt. So remember, a volt is joules per coulomb. So we can rewrite that as 1.619 joules per coulomb. And then our coulombs cancel out. And we're left with 1 electron volt being 1.6 times 10 to the minus 19 joules. So let's have a look at an example of that. So we're given the potential energy. We're asked to translate it into electron volts. So all we need to do is to divide that by 1.6 times 10 to the minus 19 joules. And we will end up with our electron volt calculation. So I'm just going to check Cognity for this. This is straight from Cognity, by the way. So this is 3.8 times 10 to the power 13 electron volts. Okay, guys, so that's the end of this second part 2 tutorial. Have a good weekend, guys, and we'll see you back next week. Bye-bye.